In this video, I will talk about an example of the funnel algorithm to have an overall idea of the mechanism behind this algorithm. And notice this example is from the article Simple Stupid Funnel Algorithm, and you can check it out on my funnel project webpage. And also, I will publish all of these materials on the website, so you don't need to worry about it. Okay, let's talk about the example. Before getting into the example, let's briefly introduce the pursuit code of the funnel algorithm. It's very easy. Every time we process a new portal edge at a time, or to say process a left or right vertices. So what is the portable edge? And as you can see, these dashed line or internal diagonals are portable edges. And left or right vertices are the ones on the chain. So let's assume vertices on this chain is the left vertices, and assume vertices on this chain is right vertices. Of course, you can flip them around. It doesn't matter, it's up to you. So every time we process a new portable edge to see if the funnel narrows, we update to the new portable edge. And second, add current left vertices to the shortest path if right boundary crosses the left boundary, and vice versa for right vertices. So what does this mean? Let's go through this example, and I think you will understand it. The first step is we need to build a funnel. So what is funnel? So funnel is a epic point. So this is our epic point with two boundaries. So left boundary, this is our left boundary, and the right boundary, this is our left boundary. So the first step, we need to build this funnel with our start point. In other words, the start point, the green point, is our epic point, and the left boundary is the line connected the first left vertices N and the start point. Similarly, the right boundary is the line connected the first right vertices B and the start vertex. At this point, we have our funnel. So next step, we process each these internal diagonals one by one. So first vertices, so the first vertex we need to process is point M. So we need to update the left boundary to M. So let's try to update it. So we move the left boundary from N to M, and we found the funnel narrows, so it's okay. We update from N to M. And next point we need to process is point C, and we need to move right boundary from B to C. Let's update it. Let's try to update it. We move the right boundary from B to C, and as we can see, the funnel narrows, so it's okay to update. And the next point is D. So we move from the right boundary to it. We move the right boundary from C to D. And as we can see, the funnel becomes smaller, so we can update it. And the next point is K. We need to move the left boundary from M to K. But at this time, the funnel becomes larger, so we don't need to update anything. So go back to point M. And next point is point E. We move the right boundary from D to E. Well, at this point, as you can see, the right boundary crosses the left boundary, so we need to add the left vertices to the shortest path and initialize our funnel again. So let's do the updation. So first add the left vertex m to our shortest path is this one, and then we move the epic point. We move the epic point from start point to point M. Let's make it green and reconstruct our funnel. The right boundary is MD and the left boundary is MK. Okay, at this point we can run the algorithm again. And the next point we need to process is point E. So we move from D to E. Okay, it's okay to update. The funnel becomes smaller, and the next point is point J. We move from K to J, and the funnel becomes smaller. Okay, it's okay to update. And the next point is move from E to F, and this is okay. The funnel always becomes smaller. But as you can see, if we the next updation is either from J to I or from F to G, and those two updations are invalid because the funnel becomes larger, so we don't update. At this point, we don't have other vertices to process, so we're done with our algorithm. Of course, we need to add the endpoint, the green point, to our shortest path. And as you can see, if we connect it from the point in the shortest path, that is from the start point, green point, to point M, and to point M, we connected the endpoint, the red point, and we compute the shortest path. So at this point, I think you have an overview idea of the funnel algorithm, the mechanism behind the algorithm. It's not that hard, it's very easy to compute, to understand. So for the next video, I will talk about the time complexity of the application. We will see or discuss what the time complexity for each main algorithm. And I will talk about it in the next video. Thank you.